All right, a couple new theorems we're going to look at today in lesson 47, the side-splitting theorem and the angle bisector theorem. Actually very simple and almost common sense-like theorems. So first, the side-splitting theorem. A line parallel to one side of a triangle divides the other two sides proportionally. So what does that mean? See how we have this, for example, this side right here. I want to change colors. Right here. We have this side right here, and we have this side right here of this triangle. All right? Because we have this splitter and this side splitter, okay, and they are parallel, it divides the sides proportionally. Okay, so, and the same thing with this one right here. So all the pieces that are created, AB, BC, CD, are all proportional to AG, GF, and FE. So you get all these proportions that now come from the splitting of those sides, as long as the side splitters are parallel. Okay, so I'll just go through one of them. BC, and I'll change colors. BC is to CD as GF is to FE. See, the sides are proportional. So if this is 2 and this is 3 and this is 4, see how it doubled? We know that this one would double and be 6, for example. That was I just made that up, right? The sides are proportional. We've done proportionality, so we know how proportions work by now. But this is just showing that if we have the parallelism, then the sides are split into proportional sides. So we're going to do make some proportions here from this picture. So BY, okay, BY right here is to BD, that's this whole piece right here, as what? And I'll change colors. As TM is to this whole piece, TE. So that'll be TE. Okay? And I'm just going to redo this here. AY, so AY is this whole piece here, is to AM, as DY is to EM. Just have to match up the corresponding pieces. And then TE is to BD as blank is to AD. As blank is to AD. Well, it would have to be this one over here, which is AE. All right, that would be AE. So we're just writing. Oh, and I even put the answers there for you. Look at that. I didn't even mean to do that. So there's the answers for those two. Okay. I think one of them was even wrong. ME. That one said ME. Was that wrong? BY, BD. Yeah, TMTE. Yeah, that said ME. That was wrong anyways. I don't know why that was there. Okay. Solve for the missing lengths. So now we're going to actually do proportions here. So this one's going to be, we can do, to find x, all right, right here, we could do 15 is to 9 as 13 is to x. Now I'm not going to solve, I'll solve. 15x equals 9 times 13, whatever that comes out to be. And then we divide by 15. I don't want to show all the work because I'm just trying to get through this for you, and it's 7.8. And then if I wanted to find y, I would set up a proportion for y, and I could say 15 is to 21. So 15 is to 21. So this is to this, as 13 is to this piece, right? This is to this as this is to this. So 13 is to y. So then we have 15y equals 13 times 21. Cross multiply and divide just like every other proportion we've ever solved, and you're going to get 18.2. This one here, we can do, to find x, we just got to find x. We could do 16 is to, no, I'm sorry, I'm thinking of a different one. Okay, so this one here, if this is 5 and this is 4 and this is 5, see how these are both 5? So these both have to be 4 then, so x is just going to be 4. So that one's actually easy. We don't even need a proportion for that one, but it would be 5 is to 5 as 4 is to x. And of course you can do that in your head. 5 is to 5 as 4 is to 4. This one here is going to be 16 is to 18. 16 is to 18 as 5 is to x. I did that ahead of time. Where did I get that from? Well, x is this piece right here. So that's going to correspond with this piece, which is 5. That's why I did 5 over x. And then 16 is this whole piece here, because 18 is this whole piece here. You got to be consistent. So it's this is to this, the whole is to the whole, as to the piece is to the piece. And you got to be consistent. So 16 is to 18 as 5 is to x. 16x equals 18 times 5, which is 90. 16x equals 90, and then divide by 16 and you get 5.625. 5.625. They don't work out nice. They don't necessarily work out nice. Now, the one case that'll be a little tricky maybe is if you have, see how they're not using these sides here. They're using the parallel. They're looking for the parallel piece. If that's the case, you have to kind of separate the two triangles that are given. So we have one triangle here, and we drew it down here, and then we have the big triangle that we drew right here. Okay, and if you separate the triangles and do a proportion, it makes more sense. Some people think, oh, okay, 7 is to 14 as 5 is to x. That is incorrect. That does not work when you have the piece of the base. It only works if you're splitting the sides. It's side splitter. Okay, if it's not side splitter, this is not side splitter because this side was not split. Okay, it is a full piece of the triangle. So you have to go back to traditional proportions with the corresponding sides like you had done, we have done in the past. So we would do 7 is to 21. Now 21 is the whole piece, 7 and 14. 7 is to 21 as 5 is to x. As 5 is to x. That would be the correct ratio there. So we do 7x equals 105, and then we divide by 7. And I don't even think I worked that out, but that's how you would do that one. Okay, I didn't even want to solve that one. I just wanted to show you what the correct ratio would be. All right, and this one here is an example of that situation. So we would have this little triangle here, and then we'd have the big triangle. So it's 8 and 6. And the big one would be 14, 8 and 6, right? The big triangle is 8 and 6, 14, and this is x. So now we're going to have, we would solve 8 is to 14 as 6 is to x. 8 is to 14 as 6 is to x. See, I'm being consistent. Top, bottom, side, side, bottom, bottom. 8x equals 84. And then x equals 10.5. So you'd have 10.5 there. All right, the angle bisector theorem is very simple. We're going to fly through this one. The angle bisector theorem says the bisector of an angle of a triangle divides the opposite side into two segments that are proportional to the other two sides of the triangle. So if this is the angle bisector, see how the angle was cut into two congruent angles. Then that angle bisector splits this side into proportional sides to the other two sides. So these are going to be proportional to these pieces here. So 6 is to 10, 6 is to 10 as 4.5 is to x. Okay? The angle bisector splits the side into proportional pieces. and then we obviously solve it and get 7.5. So there's an example that's done for us, and now we're just going to do these, and we'll be done on the video. We'll practice this in class tomorrow. So for this one here, we would have 14 is to 12, following the last example, right? 14 is to 12 as x is to 10.5. And then we cross multiply. 12x equals 147, and x equals 12.25 when you divide it out. And this one here, this one's easy. 12, I'm going to do it down here. 12 is to 12 as 7.5 is to x. 12 is to 12 as 7.5 is to x. Well, if this is 12 over 12, this needs to be 7.5 over 7.5. So x equals 7.5. If you didn't understand that, you could just do it out the regular way, cross multiply, divide, and you are done. I will see you in class tomorrow.